Good morning, India. Good afternoon, Australia. Thank you for the introduction. My name is Cesar Ortega Sanchez. I'm academic lead of the Engineering Foundation year at Curtin University. And it's my privilege to be here today speaking with you, sharing some ideas that I have about student learning. I have to make the disclaimer that this is a work in progress. I've been working on these ideas for some months, if not years now. I have facilitated workshops with these ideas. I recently presented a keynote speech using almost the same set of slides. So it's a work in progress, so bear with me. And I hope you like what I'm going to present. This is what I'm going to be covering today, a little bit of a context on where I'm coming from, a little bit of reflection on students today, the problematic around their profile of some of them, a possible solution, and the jigsaw puzzle analogy to conclude. So context, universities, the role of universities has changed dramatically in the past 20 years, in the past couple of decades, from the turn of the 20th century, I would say. Since the advent of the internet, information started to become available everywhere, right? Before the internet, students came to universities for the information, for the libraries, basically. Since the universities were invented more than 1,000 years ago, the main thing was the libraries, right? The monasteries in the beginning where the libraries were, where books were kept. So people came to universities for information. I remember myself when I did university some decades ago, it still was like that, right? I had to go to all lectures. I couldn't skip lectures because if I missed one, my option was to go to the library, get some books and make my own notes, right? Nowadays, that's not the case. Information is everywhere. Students don't need to go to the libraries or come to university anymore to have access to information. So the paradigm has shifted from the sage on the stage paradigm, when, you know, one wise person is at the front of the class, delivering content to students, and the students were passively receiving that content, right? Some of them taking notes, some of them paying attention, others taking a nap or Facebooking at the back of the room, right? And that model has changed to something where the student is more involved, where the students learn not from what we do, but from what they do, right? Active learning, flipped classroom, all those keywords, buzzwords are the way students are learning now. So students come to universities now for experiences, not for information. And that's a very important thing to keep in mind. Another phenomenon that has happened is that higher education, coming to university, has become very democratic. We have opened the doors to diversity of all kinds, you know, from people with disabilities to people with different socioeconomical backgrounds. We want to make university education accessible for all. And that's fine, right? That's excellent. But that also it comes with its own challenges, because every student comes with a particular set of needs, right? Every student, not just students with particular identifiable needs. Every student has different needs. So the more diverse the cohort, the more difficult, the more challenging it becomes to design activities and design material that will engage everyone, that will be useful for everyone. So it's challenging, right? It's tough to be an educator in higher education these days. And on top of that, in 2020, COVID came, hit us really hard, and we have to move from face-to-face teaching mainly to purely online teaching, right? And that was hard. That was hard. We at Curtin, we had to switch from fully face-to-face to fully online in a couple of weeks, right? Complete the semester 1, 2020 in online mode. It was tough. We learned a lot in the process. Technology raised to the challenge, I would say, and tools like Zoom and WebEx and all these video conferencing technologies raised to the challenge and supported us. And here we are today, right? Having a webinar with India and Australia and academics from different parts of the world using the technology. So that's some learning that we had from it. So what are our students today? So all this has led to people really studying students, right? So, and students are having impacts, have been impacted by all these phenomena. And there are people doing research on students' well-being, on students' mental health and the student experience. And that's a reality, right? That's something that is happening. And we need to be aware of it, right? We educators in higher education, regardless of whether we are doing formal research in students' experience, we need to be aware of these facts. So students' performance, right? I put here what I consider a typical, or maybe not so typical, but it's a normal distribution of marks for students, right? That more or less reflects the diversity of the cohort, right? We have always our high achievers on the right-hand side of the distribution, right? That minority that will learn regardless of what we do, right? They know how to learn. Everything works with them. Every activity, every document, every technique that you want to try will work wonders with this cohort, right? Because they are really good learners. But on the other hand, there's the other side of the spectrum where no matter what you do, students won't get it and will find it challenging and difficult, right? And it's always like this. And then we have the bulk, right? Though that big 80% in the middle that where we can make a difference. The quality of your material, the quality of your activities makes a big difference in how these students learn and achieve. So the students I'm going to be referring to today, and this is the main subject of my talk today, is the students who struggle, right? Those students who seem lost, students who don't know how to ask questions, students who have a blank expression when you are delivering a lecture, when you ask a question and you see nothing going in there, right? There are some, and this is scary. I personally teach a big unit in first year, 350 students. I personally facilitate workshops and tutorials for that unit. And I have had, scary experiences with students who really don't have a clue. And that started me thinking, and some of the ideas I'm going to present today come from those reflections, right? My own practice, my own experience, and also from reading the literature about the student experience and how people learn in higher education. So if I want to, if we were face to face, I would probably ask you to complete this phrase now. I wish my students, right? And I have done this, as I said, in workshops and conferences and with my colleagues here at Curtin. And everybody has some ways to complete this phrase. For the sake of recording, I'm not going to go with the activity, but people wish students attended lectures, students asked more questions, students took notes, students were more engaged, students gave priority to university life, students knew how to work in teams, how to communicate. So there's a big wish list of things that we notice as academics, we notice, right? Some students lack many skills and abilities and knowledge. I'm going to make some sweeping facts about our students, and when I say our students, I'm referring to these students and not necessarily the low achievers. This could apply to almost the whole generation, right, of millennials and Gen Y. So most university students these days were born in 2000 or later, right? They are in their early 20s, where it's 21st century. The internet and mobile devices have been with them most of their lives, right? And they spend a lot of time, a lot of their experience happens in this space. They have been bombarded with information all their life. They don't understand the concept of books and libraries. They are used to get instantaneous answers. Just Google anything, go to Wikipedia, you can find anything instantly. So that's their experience. But there's a lot, right? That comes with a downside. It's too much. Nobody taught them how to manage that tsunami of information. So they are confused. For them, they don't have a framework for discriminating and analyzing and assess the quality of the information they are receiving. So for them, Facebook, a post in Instagram, and a post in Scientific American are probably the same, right? It's just different opinions, different outlets of information. So it's a bit of a problem. Some of them grew in an overprotected environment, you know, all these parents, helicopter parents with hundreds of activities for kids and constantly watching what they do and how they perform, and very involved and overprotecting them, right? They didn't allow their kids to struggle, to face adversity. And that comes with some negative consequences. I don't know, in India, in Australia, I have the feeling that the school system rewards effort, not performance, or mainly effort rather than performance. And I'm talking about, you know, in primary school, everybody gets a diploma, right? And you go to a ceremony and everybody gets a diploma, right? Some for punctuality, some for being good citizens, some for academic achievement, but everybody gets a diploma. So, and the message, I think, is, you know, as long as you're doing your best, is fine. Don't worry about becoming the best or being better. And I understand the logic behind it, right? Some students can cope with competition, but what about those who can? What about those who can be better? Right? I think not rewarding performance, not distinguishing and making competition open leads to lowering the standard, to lower levels of quality in the education. Some schools, again, some schools, not all schools, but some schools are more interested in the ranking than in educating people, right? And I have attended, you know, meetings with parents in my own kids' high school, I remember, and the person there was saying, advising parents or kids not to take physics in high school because it's too difficult. And the ranking of the school comes down when they do the state exams, right? So don't go for physics, it's too difficult. I say, what really? I mean, what about the engineering, right? The engineering needs physics. You want good engineers, you need these kids to take physics, regardless of if it's too difficult or not, or the rankings, right? Again, not all schools are like that, not all teachers are like that, but it happens, right? And our kids are exposed to that. And along, etc. Right? You can complete this, and probably you have kids, you have all of you probably teach and probably know what I'm talking about. So what happens then? All this context, all this environment leads to what? Well, what have these kids learned, right? They distrust information. As I said, they don't know, they don't have a framework to assess and evaluate information. Therefore, they distrust everything, right? Everything is an opinion, everything is fine, you know, the earth is flat, well, that's what you want to believe, right? The earth is round, well, that's what you want to believe. They don't have a framework, right? All knowledge is relative, it's a point of view. And social networks taught them they are always wrong. Whatever they publish, whatever we publish, somebody will come and hit us in the head, right? You're wrong, and they cite papers and people, and unfortunately, humans have this trait to stick to negative feedback rather than positive, right? So if a girl in high school posts something, a photograph of themselves, and everybody says, oh, you're pretty, beautiful photograph, etc. But one person says, oh, you look fat. What message gets in the head? Oh, I'm fat, right? So we have that trait, that tendency. So and that's bad, right? So what happens with this? Well, they trust no one, not even themselves, and that's really, really critical. And hence, to me, that's how I explain those blank expressions when you're asking a question in class. I'm pretty sure they know something. I'm pretty sure they have something to say, but they don't trust them, even themselves, what they know. They distrust information. They don't trust even themselves. They are incapable of seeing the big picture, right? Everything is instantaneous. Everything it's happening now. And if you talk about investment in your education for the future, for them, the future is this afternoon, right? What I'm going to do this afternoon, let alone next week, next month, next year, right? That doesn't exist. So some of them, and again, remember, right? This is for some students. I'm not generalizing. It's just for some students that have these traits. They are incapable of seeing the big picture. And that's my latest conclusion. Some of them, they know deep down, they don't need to learn, right? Or they can learn even, right? Why bother? I can Google it when I need it, right? So they have this idea that learning is access to information, and that's really, really bad. So what do we do about this? Well, if they trust not even themselves, well, we as educators, we have to gain their trust. We have to boost their confidence. We have to make them understand that the information they are receiving at the university is good information. The activities they do at university are good activities, right? So gain their trust, boost their confidence. They are incapable of seeing the big picture. Well, show it to them, right? Explain it. We can be more explicit in why we do things and what's the long-term implications of learning what we are trying for them to learn today. They believe deep down they don't need to learn, right? And what do? Well, prove them wrong. Prove them wrong. Prove them that they need to learn. Prove them that they can learn. You know, that it's possible to learn. And that's it, right? We do this, we solve the problem. Okay, well, yes, but how, right? The thing is how. We are talking kids who don't know how to learn, and we want them to learn this, right? So it's like having a poor person and just telling them, get some money, right? Get some money, and that solves your problem. Well, yes, but how, right? The how is the trick. So having this conundrum of how you teach someone to learn when their problem is not knowing how to learn is a big conundrum. So we could go, we couldn't, I mean, we could, but we shouldn't go the theory way, right? And explain to these students that there are theories of learning, you know, and we could talk about cognitive psychology, behaviorism, constructivism, social learning, socio-constructivism, experimental learning, multiple intelligence, etc., right? Scaffolding, because they won't understand, right? We are talking people for whom many concepts just go over the heads. When they hear something, they cannot connect the ideas. They cannot identify the main concepts of what you're saying and making connections with their previous knowledge and their current knowledge and the new knowledge. So all of this is good for us academics. You know, we need to be current and we need to know about these things, how people learn, a little bit of psychology, good pedagogies, etc. But not for students, right? So I thought, how can I come across to these students, right? How can I help them develop the skills they need to start learning? Because some students, believe me, I mean, some students in first year of engineering, I have the feeling they forgot how to learn or never learned how to learn, right? Which is even worse. So I came up with this idea, the jigsaw puzzle analogy, right? Learning is like putting a jigsaw puzzle together, right? It takes time, right? You can rush it, and everybody will do it at its own pace, at its own rhythm, right? You can't rush it. The same experience putting the jigsaw puzzle together, you know, having 500 pieces on a table is perceived different by different people. And I have run workshops with 500 students, you know, teams of 5, you know, 100 teams, putting a 500-piece jigsaw puzzle together in 15 minutes. And you can see beautiful reactions. Some of them very enthusiastic, embrace it and feel the challenge and say, yes, I will do this. Others just freeze in panic and say, oh my God, this is impossible. It's impossible to do, we'll never do it, right? Others go and start quietly putting pieces together, working on their own. Others immediately start dividing the job between the team and start working in teams. So you see all these dynamics developing, right? And it's the same activity. So the same experience is perceived differently by different people. And that happens in teaching, right? Requires discipline and motivation. You need to make the time, you need to invest the time, you need to focus and do what you need to do and do it. And you need to be motivated, right? With no motivation, it's really difficult to complete a jigsaw puzzle because it requires patience and resilience, right? The management of frustration, of adversity. And you have to be patient. You have to keep going, you know, maybe it doesn't make sense now, but it will make sense later. You have to have that certainty that if you keep doing it, you will start seeing the light. So it's very satisfactory when pieces connect, and that feeling of learning, you know, when you finally say, ah, now I get it, right? This and that connects into this new concept. That's a fantastic experience for us learners, and it's similar to what we feel when we find that piece in the jigsaw puzzle and you connect it and say, yes, it goes there. The skills we learn from putting jigsaw puzzles together are transferable, and hence the beauty of it, right? So my proposal here is, you know, you have trouble with students learning, make them do jigsaw puzzles, and then we'll develop these skills. So coming back to our problem and how we solve the problematic that some of our students face these days. Well, the knowing the big picture is like having show them the box, right? It's how you have these 500 pieces there. They make no sense, you know, and that's day one of your lecture. You know, I teach electrical systems, and the first day, if I just show the list of topics there, you know, Ohm's law, Kirchhoff's law, AC analysis, motors, Arduino, programming, sensors, networks, they just go confused, right? They don't see anything. But if I show the box, if I explain to them what the electrical systems are and why it's important that they learn and how a civil engineer will apply electricity in their practice, then it makes more sense to them, right? It doesn't matter, they will understand that it doesn't matter, I don't understand the pieces now, I don't understand those words on the slides now, I know there is a purpose, I know there is a framework, so that's important. Now, get organized before starting, have a plan, you know. What do we do when we have a jigsaw puzzle together? We separate the pieces, right? We put them all facing upside up. And we have a plan, right? We know, well, maybe I start by sorting out the edges, and then I separate by colors and by shape, and I orientate the piece. I don't know, you know, different things. It's the same in education, right? When students do an activity, go to a lab, a workshop, tutorial, when they enroll in a unit, when they enroll in a course, they need to have a plan. They need to be able to visualize in their head what they're going to be doing. Start with the easy ones, right? Scaffolding, you know, don't throw big concepts at the beginning. Don't try to swallow the whole elephant in one bite. You know, start with the easy ones. Make explicit the expected knowledge you want them to acquire. Give a good review of fundamentals. You know, the fundamentals that they will need to understand your content. Point to additional resources. You know, so let them know. Show them the way. Give them a solution to the problem of how do I approach this content or this unit or this activity. Separate the edges, get to know the pieces, discover tricks, right? So I personally like putting jigsaw puzzles together a lot, and this is one of the things I do to put together the edge. Well, I separate the edges before, and then I orientate all the pieces in the same way. That way, I turn a 2D problem into a 1D problem. All I have to do is find the right place in a line, right? And then all I have to do is rotate the lines and I get my edge. So that's a trick I discovered by putting jigsaw puzzles together, right? And the same happens in education. We have tricks, take notes, highlight, fold the page, of the book, or use bookmarks, or use links, or watch videos, or find interesting resources, review before, etc. Right? Everybody needs to discover their own tricks, and we can share our own. Right? And it has to be explicit. Complete the edge first. Understand the scope and limits of the content that you are learning or teaching. Know the limits and expectations of what you are learning. And that gives you a framework, right? That gives you a framework, a boundaries of what you can expect and not expect from what you're learning. And those expectations are important. Then classify the pieces, divide and conquer, learn the content, and we can help students doing this, right? If we organize our content in a mind map, in a diagram, in a map. Some people, I have seen people using physical, geographic maps, and they say, this is a journey and this is the path we're following, and they have stations and places they visit in that map. It's possible, right? But the idea is show them the individual components of what they're doing, and show them a path, right? They don't have to assimilate everything at the same time. There is a process. Focus on one feature at a time. Focus, see, here the active word is focus. So learn to ignore the big picture for a bit and just focus in the concept at hand, right? Identify and connect pieces that go together, right? So in a lab, in a tutorial, in a workshop, students need to do this. In lectures in particular, it's important that they can identify and connect new concepts and where they go. And this is very powerful, right? That's how we learn. That's how people learn. We associate information with each other. We make connections. So if we have in our head this mental map of the red pieces, the yellow pieces, the green pieces, when a new piece comes and it looks green, well, you immediately go and brings back all the green pieces and start trying to make connections with it. That is a very powerful analogy on how we learn. That's how we build knowledge in our brains. Gaps in the puzzle can guide your search, right? This is the missing knowledge. This is how we ask questions, right? If we have a picture and we have an expectation, we start seeing the picture, right? As you put pieces together, you start understanding more and you say, oh, that makes sense. Oh, now I think there's a yellow piece here. That's your question, right? I can see all this, yellowish picture, but I think there is a big piece missing here. Isn't that right? I think that's the beginning of a very good question. Step back and check your progress, right? Always reflect on your own learning, reflect on your activity. So where are we with regards to the big picture, with regards to the edges, the total contents, right? And this reflection, right? This is connected to reflection, to reflecting on how we learn, what we learn, why we learned it, constantly, right? So it's good to focus at some point, ignore the rest, but then the contrary happens. You go back, step back a couple of steps and see what's happening. And sometimes those of you who put jigsaw puzzles together, you probably have experienced that when you have been struggling for a bit, sometimes hours finding something, then you just step back and suddenly you start seeing the puzzle with different eyes, and immediately you start finding pieces that you thought were lost. Sometimes happens. And then the jigsaw puzzle is also a very good analogy for bad learning, right? This is a student saying, yes, I got it. I just crammed the content the night before the exam and I will pass, right? Or I just copy from somebody else and here it is, right? So these are students who believe they are learning by taking shortcuts, right? Like this, I love this picture, of somebody who say, yeah, I nailed it, right? It's finished, I done it. Well, it's not like that, right? It's not like that. You need to really walk the walk and spend the time and commit to the activity. Otherwise, your learning is going to be not good. So in summary, we can use the jigsaw puzzle analogy in learning, as learners, as for our students, because I show this to students as well. To learn to recognize and classify the information. Don't just collect the facts, connect them, right? Because if you go to a lecture and you just listen to the lecture and you pay attention, right? You're hearing, but you don't consciously make an effort to connect the new information with old information and to classify it, and knowing what that piece of information is, where does it go in the totality of your intellect, then the learning is suboptimal. Approach learning with a purpose, expect something from your lecture, from your activity, from your lab, from the quiz you're going to do. Don't lose sight of the big picture. Always remember that the details, the activities you're doing today may look simple, may look irrelevant, boring even, but have awareness that they are part of a big picture and they are an important part, right? Every piece in a jigsaw puzzle is important. There's nothing more annoying than a jigsaw puzzle with a missed piece, right? When there's one piece missing, oh God, this is like a splinter in your brain. Know that perseverance leads to success. Learn to be resilient. Learn to be to deal with adversity, and just keep going. Just keep going. And there are many ways to achieve goals, right? Everyone is different. The same activity will be perceived completely different by every student. And the same happens in your lectures, right? When you are delivering a lecture, when you are facilitating a lab, a workshop, a tutorial, every student will be perceiving differently. And you will see some who panic, some who enjoy it, some who engage, some who get bored, some who are not interested, some who are very interested, the same activity. And that's normal, right? And you as teachers need to understand that. And we as learners need to know that it's okay to be bored, that it's okay to engage, right? Doesn't matter if nobody else is engaging. If you want to engage, engage. Respect it. Know yourself and respect it. Now, as teachers, one thing we can do is tell them about the analogy, right? Tell them that learning is like putting a jigsaw puzzle together. And obviously, this will say, oh, well, many students will say, I learned this in kindergarten. Well, lucky you. But that 10% who didn't know this, and I have had students say, oh, that makes sense. Oh, that's a beautiful analogy. They like it. They connect with it. There are some students who need to hear it. And yes, you're going to bore to that 90% of your class by telling the analogy, but the other 10% are those who are sitting in that 40, 50%, and maybe, just maybe, some of them will jump over the fence to be more confident learners. So tell them about the analogy and keep reminding them about it. How do you do that? Did you notice my jigsaw puzzle pieces on the slide? That's a subtle reminder that everything you do, you learn, is part of a jigsaw puzzle, is part of a bigger picture. And that's it. I don't have to mention it even. Just by putting my little icon with the jigsaw puzzles on the corner is enough for them to be reminded. Tell them about the big picture. Show them the box, right? For every activity, for every lecture, for every unit you teach, tell them why they are doing it, why it is relevant, where does it sit in the context of other units, of other professions, of other activities. They need to know. When you have the big picture, it's like having the edge of your puzzle. It helps you, it guides, it may guide your learning, your activity. Show them how to identify and classify information. You can do that by role modeling, by doing it yourself in front of them. You could create a video, right? Or for your particular practice, for your particular unit on how to identify and classify information in your unit. Make links between information explicit. Tell them how to put the pieces together. These are two red pieces. This is how you connect them, right? This is Ohm's law and this is Kirchhoff's law. This is how you put them together. Make links between information explicit, encourage them to persevere, keep reminding them that they need to keep going, right? They have to be patient, they have to be resilient, just keep going. And give them time to reflect. Also encourage them to keep thinking about their own learning, about what they learn, why they learn it, how they learn it, because that also will help them become better learners, better students. So there are some other uses of the analogies, right? And that's bigger picture, right? These learning activities are like pieces of a big puzzle, in your course, your unit, your course. Then the units are pieces of a bigger puzzle, which is a program, right? Engineering is comprised of this so many units, and this is how they fit together. There's a big picture for that, university is a piece of a big and even bigger puzzle, life, what role your education will play in the big picture of your life. Assessment becomes a demonstration of how well can they see the big picture and how well they can apply what they see to solve problems, right? That's, for us engineers, that's critical. And that's what we want students to be able to do, right? That they can recognize the tools, the knowledge they learn in our units and use it to solve problems. And you can complete this picture, right? I mean, I'm pretty sure you have ideas, and perhaps we can have a small conversation about this later on how to use the analogy and extend it to other domains. So that's basically the end of my talk. I put this couple of pictures to just ask the question, right? What kind of graduates we want to produce? Because make sure many students will graduate. We are graduating many students, but I can tell you, some students are like the one on the left, right? With sacks full of pieces of information. They have no idea what that information means, what is useful for, how to use it to solve problems, right? To different levels or different extents. But there are other students who got it from the beginning, and they know exactly what they learn. They see the big picture, and they will be fantastic engineers and human beings for the rest of their lives, right? So what kind of graduates we want to create, and think about it, right? The jigsaw puzzle analogy, I think is very powerful. And well, that's the end of my talk. I hope you enjoy it. I put a couple of references there just in case somebody's interested. I thank you all for your attention, and I send the control back to
Yes,
the
thanks, Cesare.
I'm going to stop sharing, right?
You can just keep it if you want. Is there like, well, first of all, thanks for this interesting presentation, and that's very interesting analogy that you use with jigsaw puzzles. Let me see if we have questions from the audience. Selvan says, excellent talk, Cesar, thank you. I want to ask you a few questions, but just if anybody else would like to ask, please feel free to write it down in the chat. The question that I wanted to ask you, right? So you mentioned that you teach like first year students, right?
Correct.
So is it like mostly for like first year students, the one that's this kind of analogy, but also it will work kind of well for different years?
Well, so I said at the beginning that I think this is important to know to that particular cohort of students, the weak ones, right? The ones that have no clue. I think when they reach university, perhaps it's too late to talk about these things. I think these concepts of the jigsaw puzzle and how learning is like putting a jigsaw puzzle together should be taught since kindergarten, right? And maybe they do. I mean, that's why kids do jigsaw puzzles in kindergarten. That's how they learn resilience, and their brains in development learn to find satisfaction in finding pieces and putting them together, right? Maybe, I don't know. Maybe it should be done more in primary school, high school. University, in my view, is remedial. It's too late. But still, as I show in my last slide, I'm pretty sure we have some graduates who struggle articulating what they learned and how they can apply what they learned to the work. So even if after graduation, they see the analogy and they say, oh, I wish I had known this earlier, but they can apply the concepts for the rest of their careers, is fine. I think, the earlier the better, but I wouldn't say this is particular for first year students, no.
Okay, thanks. By the way, did you get any feedback from students when you talked to them about this analogy? So did they say, well, that was a great thing, or just anything from the students? Any?
Yes, yes. I asked for feedback on the
Uh-huh.
activity because I run this at orientation, right? First activity they do when they come to Curtin in engineering, one of the activities is the jigsaw puzzle activity. And as I described, they work in teams,
Okay.
and I have 100. And the feedback was mixed. Most of them like it. No, nobody hated it. Everybody enjoyed it. When I asked about how useful it is, the majority said, well, I already knew this, right? I already knew this. But there was a minority, I must say, probably 10%, who said, yes, it was very useful. I never thought about learning about like that. And I think this is going to help me in my learning. Those are the ones I'm after, right? But yeah, that's what students say. They like it because they see it like a game, right? And perhaps that's why they some of them get disappointed. This doesn't look like a university, something you should be doing in university, right? It's too simple. It's a game. Right? I don't come here to play games. I come here to become an engineer. Well, engineers should know do this, right? They should be able to do this very well.
Yeah, thanks. Here, what we have, like when we have orientations, we have also like when we have school kids who come to learn about engineering at Griffith, we do Lego. So we give them Lego and ask them build a different thing so that they can also think about their like future, how like they would just consider doing this and that and build with like little blocks and like creating big ideas. We don't do like jigsaw puzzles, but Lego used to be like very popular before COVID, of course. Like after that, it's a little bit different now. I saw that we had a comment, excellent talk. Do you think there is a difference between students acquiring intellectual skills and craft skills? I think about this when I'm in a chair being treated by a dental student. They might need to know about the history of dentistry and acquire the skills of diagnosis, but I want them also to know how to use a drill or probe safely. That's a good question. So the question is,
the difference between acquiring intellectual skills and craft skills. Yeah. So I suppose this is bigger, right? This is learning in general. I think the skills you need to learn to learn the tools, to learn how to use your hands. I'm thinking dentistry. How to handle instruments, etc. I think it applies. It's the same. It's practice, right? As you put jigsaw puzzles together, the more jigsaw puzzles together you do, the better you become at it. So you learn by doing, right? So I think it applies well. And for the intellectual side of things, I think I focus more in my talk about that, is how we connect ideas, how we create knowledge in our brains by putting pieces of information together in different ways. So I think, yeah, you could extend the jigsaw puzzle analogy to skills or intellect, because it's about learning, right? And learning is universal. So I think we can do both. I wanted to say something about the Lego thing. One problem, well, first of all, great activity. We do also cranes with Kinects, etc. I hope you make explicit why they are doing it. You show them the big picture. You show them the box of the Lego activity, because otherwise it just becomes a game, right? Just, oh, no, let's play together with Lego. Yeah, but if you tell them, you make explicit the big picture, the box, that would be excellent. And one reason I thought of Lego when I was thinking for something that was, fundamental and base level. One problem I had with Lego is that all the pieces are identical, which may lead to another analogy, interesting analogy. But I like about jigsaw puzzles that every piece is different, and that's perhaps more suitable for learning discipline content, right? So every piece of information is different, comes from different sources, connects in different ways with other information, etc. Right? But yeah, I suppose, you can say that if you make the box explicit, any activity that involves building, constructing something from little pieces will work.
Yeah, thanks, Cesar. Are there any more questions?
Hi, Caesar. Thank you for the talk. That was really interesting. And it got me thinking about the analogy too, and just maybe an extension of it. I was just thinking, because I've been speaking with a student recently, and it got me thinking that some students might feel like they actually have more puzzle pieces than others, such as students with learning difficulties like dyslexia or mental health issues like anxiety, and especially anxiety around learning, or students with, lots on their plate beyond just their studies, like work and family responsibilities. And we all know, especially with COVID, during we had lockdown, we had homeschooling to deal with our kids, we had sick family members, things like that. And so it just got me thinking that those things might make the learning puzzle, as you say, even more challenging for some of our students. And we just always need to have that in the front of our mind. It's very easy for us to be very focused on, delivering our course, and we can actually forget sometimes that there's a lot of things that influence the individual students and how they complete the puzzle, and maybe how fast they complete the puzzle, and things like that. So yeah, it just got me thinking about that during your talk, and I wanted to say thank you.
You're welcome. Thank you. And very interesting points you make there about the students with special needs, when they have a disability. We deal with many of those here at Curtin too, different kinds of disabilities, from visual to mobility to intellectual. I think the first step is for the student to acknowledge that they have a disability for that particular activity, right? So I am dyslexic, or I am colorblind, and these pieces the colors confuse me, right? So you can change the puzzle for something that doesn't have those colors, right? I'm visually impaired. I can't see the pieces. Well, there are puzzles with bigger pieces, right? Or you can make the pieces bigger, or you can give a magnifying glass. I don't know. So yes, we need to be mindful that as I said, the same activity will be perceived completely different by every student, not necessarily disabled students, students with disabilities. Every student will perceive it differently, but they need to identify. They cannot expect us to guess what they need, right? And I'm talking in general, because that's many times, wouldn't our life would be so much easier if the students were able to say, I'm struggling connecting ideas. I'm struggling making questions. I'm struggling understanding the fundamentals. So if they could articulate their troubles and give us a hint on how we can support them, everybody would do it. I mean, our job would be so much easier. Perhaps we spent a lot of time and resources supporting students by guessing what they need, right? So I think that it's a both way thing. There's a responsibility on the student to tell us how we can support them when they need bigger pieces in the jigsaw puzzle, because we can guess. We can have a puzzle with big pieces, a puzzle black and white, a puzzle just in case, right? Because it's too expensive, time consuming, and most of the time they won't be needed. So yeah, it's nice extension of the analogy, I suppose.
Thank you, and thanks for the great talk.
Thank you for listening.
Could I ask you another question? Sorry, I was the dentist chair one.
Yeah, go ahead, yeah, Paul. Yeah,
confession. I just wonder what your thoughts are on what seems to be becoming a kind of almost a kind of standard kind of pedagogical assumption now about flipped classrooms, that we don't stand up. I love that, the sage on the stage. We don't do that anymore. We give them the information, we provide information in advance that we expect students to engage with in some way, so that when they come to either face-to-face or online some other event there that will be more interactive, it's on the basis that they've kind of done some preparatory work. they've read something, they've thought about something, you know, that seems to have become an increasingly significant assumption, but it's an assumption that I don't know we're justified in making, because so often, you know, the students, maybe they turn up and they haven't done that. So it's like, what do you do when you're confronted with the blank faces, not sitting there waiting for you to give the sage lecture, but on the assumption that they've done all this preparatory work and they're ready to then have an informed and thoughtful kind of tutorial session, but they haven't read anything. It's like, you go, well, sorry, I can't, you know, it's like, I'm going to take you in a coaching session and, you know, for soccer or something, and I expect you to have turned up wearing kit and soccer boots and maybe done a warm-up. You know, if you turn up wearing long pants and thongs and you're freezing cold, I can't coach you to be a good soccer player, you know, so sorry.
Correct. Yes, well, several ideas come to my head with that question. First thing, a phrase, right? I heard this phrase some long time ago from a colleague, doctor, medicine doctor, giving a talk here at Curtin, and he said, what you permit is what you promote. And think about it, right? If you set a task, and the task is you have to read this paper before coming to the workshop, because we're going to use that information in activities, and you permit the students not to read it and come to the session unprepared, you are promoting that. So next time, why would they read if you are allowing them to come and participate anyways, right? So what you permit is what you promote. We have to be very careful about that, be very mindful of that. Second, when we are in the context of our units, you know, I teach electrical systems, as I said, I'm very mindful that students are in university first year, they are learning at least two important distinct things in my unit. Content, discipline content, electrical systems, you know, the syllabus, DC analysis, AC analysis, etc. But they are also, in every first year unit, they are learning tools and skills. And in my view, the way the world goes and what industry is demanding from our students is more about the skills than the knowledge. Because as I said, the knowledge, the information is there. If you manage your students to learn how to find information by themselves and assimilate information by themselves and organize information by themselves and find ways to use that information to solve problems by themselves, then your job is done. Don't worry about if they don't know Ohm's law, right? Because the day they need it, they will know they need it, and they will know how to find it, and they will know how to understand it, and they will know how to apply it, right? So I'm not saying they shouldn't learn any discipline content. I mean, we expect them to learn discipline content, but the conversation you need to have with your students that don't engage, that don't read, it's not about Ohm's law. It's about the opportunity they are missing out for not engaging, right? You are letting pass an opportunity to learn invaluable skills that you will need every day of your engineering life. Because Ohm's law, you know, a chemical engineer, I would guess, will never, ever in their professional life apply Ohm's law. But the ability to read a paper about Ohm's law in this case, you know, but could be anything, read a paper at home and come to a workshop to apply that information to solve problems, that ability they will do every single time of their lives, right? That's how engineers, that's what we engineers do. So we need to approach with the students, you know, the big picture, the box. The box includes content, but also skills. And if you don't like the content, you don't find the content engaging, and this happens a lot in programming, right? Some students come very cynically saying, I don't need to learn programming. I'm going to be a civil engineer, right? I don't need programming. And well, you can spend time telling them why they will need programming. But what I tell them is, okay, let's assume you will never touch a line of code in the future, right? It's unlikely, but let's assume that's the case. the skills you will develop by learning how to develop algorithms, how to translate algorithms into instructions in a program, that intellectual process is exactly how engineers solve problems every day of their life in every profession. You understand the problem, you split it into smaller parts, you find a solution that uses, etc. Right? And then some of them say, oh, okay, so it doesn't matter if you don't learn Python, if you learn how to design algorithms and how to think like an engineer, right? The students need to know that, and it's convincing. I mean, not all of them, as I said, you will never reach 100%, but those additionals, those little extras come from conversations about the box, about the big picture.
Well, thanks, Cesar. Yeah, thanks, Paul, for asking questions. I think we need to finish and conclude the session. It's already past the time we usually go for 1 hour. So thanks, everybody. Thanks, Cesar. That was great talk. We've learned about different ways to look at learning and teaching. Thanks for sharing your experience. That's really valuable. And thanks, everybody, for joining the session. Thanks for this lively discussion. And I wish you guys a good day, everybody.
Thank you for inviting me. I hope to see you soon. Bye.
Yeah. Bye, everybody.